Hello, in this video I'm going to explain the hardware interfacing programs of 8051 microcontroller lab. So in the hardware we have two programs, 8051C program to rotate stepper motor in clockwise and anti-clockwise direction, and second one is 8051C program to generate sine and square waveform using DAC interface. So let me start with the first one, the stepper motor. So this is the stepper motor interfacing diagram. So before that you should know what is stepper motor. So stepper motor is actually how it differ from DC motor is. In the DC motor we have two windings. Okay, it has only two connections. Okay, plus and minus. If you give, it will rotate continuously, and if you reverse the direction of a battery, it will rotate in opposite direction. But in the stepper motor, four coils will be there, and you have to excite either any one or two coils at a time. So in our lab, we are using you have to excite two coils at a time. So you can see the diagram of stepper motor. Okay, the center one is actually rotor, which will rotate. You can also observe uh, the row stators, four stators are there. Okay, and this is a rotor. So you have to excite. This is, for example, this is A, B, C, D coils. Okay, so first you have to excite A and B. The rotor will rotate by one step. Okay, so next these two should be excited. Next these two should be excited. Next these should, so that it will rotate in a clockwise direction. So if you excite opposite direction, AD excite first, next to DC, next to CB, next to BA, again AD, BC, so then it will rotate in anti-clockwise direction. And if you excite in opposite sequence, it will rotate in clockwise direction. So in order to rotate, change the direction of the rotation, just reverse the excitation table. Okay. So next we have, I'll show you for example, these are beginning starting point. If I excite these two coils, okay, so it will rotate by this much. So 1.8 degree or 2 degree. Next, these two are excited means now it is actually rotating clockwise. Okay, next these two. So four step sequence. So this is a step 1, step 2, step 3, step 4. In the step 1, A and D are excited. Next in the step 2, A and B are excited. Next step 3, B and C. Next step 4, C and D. Once again you have to repeat it. Okay, after these four sequence, once again you have to excite this sequence only. So this should be in sequence. Okay, like this is 9, 9, then this is 6, next is C, then 3, 9, 6, 3, C, 9, 6, 9, C, 6, 3, 9, C, 6, 3, like that. If you continuously give, it will rotate in the clockwise direction. If you give in opposite direction, for example, first can give 1, 1, no? This is 3, next 6, next C, next 9, next 3, 6, 9, C, 3, 6, 9, 3, 6, C, 9, 3, 6, then it will rotate in opposite direction. So you have to give the sequence in the proper order. If you mix the orders, it will not rotate. So next we have step angle. What is the meaning of step angle? The Viva question they will ask. So step angle is if you give one step of excitation, how much degree it will rotate. That is step angle. So usually it will be 2 degree, 1.8 degree, varies from manufacturer, one manufacturer to another manufacturer. So in our lab, we are using a stepper motor which rotates 1.8 degree. So if you want to have complete one rotation revolution, or that is a 360-degree rotation, then how many steps required is 360 divided by 1.8 is 200 steps are required. Suppose step angle is 2 degree, 360 divided by 2 is 180 steps are required. If it is 1.8, step angle is 1.8 degrees, then 200 steps are required. So you have to send the excitation according to how much degrees you want to rotate, no? That much steps you have to send. So this is the interfacing diagram. So in the interfacing diagram, this is 8051 microcontroller. Port 1 is used. So four coils are there. It's connected to port 1, 0th pin, first pin, second pin, third pin, and it's connected to the four pins of stepper motor. So this is a rotor, these are the stators, and they are connected, not directly connected, they are connected through ULN 2003. It's an IC which increase the current level, because what are the current available in the output pins of this microcontroller, that is not sufficient to rotate the motor or drive the motor. So you have to increase the current values by using ULN to it acts like a booster, it will increase the current value. Okay, this diagram you need to write. After that diagram, they asked C program. So I'm using a Kill software. In the Kill software, go to source group, add a new item to the source group, select the C file and type stepper.c and close, and you have to type this program. First line, hash include register 51.header file. So it includes all the content which is required for 8051 interface programming. So register 51.header file. Void delay. This is a delay program. Just introduce delay between two steps. If the delay is 0, then it looks like normal motor is running, DC motor is running. So if you want to rotate stepper motor in step, so you have to introduce some delay between steps. So you can use unsigned char, means actually maximum you can give 255 or FF. Instead of char, I'm using int. Int means it is 16-bit. You can give up to FFF. So you can choose any. If you give less count, if the delay is less, stepper motor will rotate faster. If I give FFFF, then stepper motor will rotate with the maximum delay. So int means it is 16-bit the data size. If I declare as char, then you can give only FF. Okay. So you can write int I. Okay. Anything you can give. Okay. Whatever you want, you can give. Int I also you can give. Anything you can give. Label. It's a label. Okay, after that, main program will start. This is a delay program. In the main open bracket, close bracket, while one is required because you have to rotate stepper motor continuously. So you have to send the sequence two coils on. Okay, it is don't give here because these are not connected to the stepper motor. In the diagram you saw only port 1 zeroth pin, first pin, second pin, and third pins are connected. So two coils are given one here. Next, these two coils are given 1 1. Next to these two coils are given 1. Next, these two coils are given 1. So it is actually shifting left side actually. These two bits coming left side. And again, these 4 bits, if you shift left side, you are going to get this. And again, if you shift these 4 bits, you will get this sequence. So that is 6C93. This is for anti-clockwise direction. For clockwise, you have to give the first opposite direction. Okay, opposite. So now here, suppose if you're getting opposite, then just change the sequence. It will rotate in opposite direction. How it is connected internally, if you have some confusion, just give one sequence. If it is rotating some direction, just reverse the sequence, you'll get the opposite. So this is while one. Okay, while one means always true, it will execute this one for infinite time. So continuously it will rotate. If you want to have stop the stepper motor after one rotation, then you have to use here for loop. Okay, for I is equal to for, you can declare one more variable j. For j is equal to 0, j less than 200, then j plus plus, it will execute exactly 200 steps. Or suppose assuming step angle is 1.8 degree, 200 means one complete rotation. So if you want to rotate stepper motor for one complete rotation, 200 steps you have to give. For j is equal to 0, j less than 200, j plus plus. If you want to rotate half, that is 90 degree, then you have to give 100 steps only. If you want to rotate 45 degrees, you have to give only 50 steps. Okay, so instead of while, you have to use for loop there. So now I'm sending the first port 1 is assigned with 06. Okay, delay. Next port 1 is given with the next sequence, again called delay. For next sequence is this called delay. Next this sequence delay. So this while one is continuous. So it will after this sequence once again it will repeat 6C93 6C93 continuously for infinite time. It will rotate. If you want to have rotation, you have to use for loop for one rotation and one and a half rotation, two rotations. So now I'm compiling this program. So your check the here zero errors and zero warnings are there. So you have to download it. Okay, for that you need to click on this button, that is options for target, and here there is a output tab. In the output tab, this should be clicked create X file. So once you selected and do this, you are going to get creating X file. You can see here created creating X file is generated now. Okay, if your kit is supporting X file, okay, then you can directly browse that X file. And in our college, we are using a old version of kits, and that kit was brought during that is a Windows XP time. So it is not supporting latest that is an operating system Windows 11 and all. It will not support. So Flash Magic is not working. So if you are using new kits, you can use suitable Flash Magic or something. So I am explaining now how to do it in Windows XP. Okay. C6, this is okay, this sequence actually have a video where they are given sequence. It's assembly program. Okay, C639. This is for anti-clockwise. Okay, for clockwise our program. So I'm just show this anti-clockwise sequence first. Okay, because in this demo is recorded for assembly program and that is for anti-clockwise direction because sequence is C639. That is opposite direction we are giving. So you are going to expect anti-clockwise direction. So first what you need to is in your you have to open in Windows XP. So Windows XP it will support only in Windows XP because that ISP programmer and the kit they provided it is old version Keel 3 they are using. In Keel 3 only you have to do. If you are having new kits in your college, you can practice with new only. Okay, in the old kit, you have to open ISP programmer where you need to convert that X file will be generated where your folder is there. Okay, you have to browse that X file. So once you build the target, X file will be generated in the folder where you created the file. So for example, here project one dot x file is created. So you have to select that and you need to convert into binary file. So same binary path also same folder only. Give some name. For example, SSS, anything you can give. Step also can give. And once you click convert X to bin, that conversion will take place from X file to bin file. Now for load, you have to download or program this bin file. So select that bin file and program. So once you click on the program, it will show uh, this message. It reset the chip. Okay, here is the code done. Writing the code. Okay, it will show the arrays, the volume, and this 100% of file is already written. So the total size of that bin file is now 31 bytes. And it is showing chip successfully programmed. So once you program, okay, see in the kit, in the 8051 has built-in RAM of 4 kilobytes. So it will be programmed in that memory. After that, once the program is successfully done, now you can check the output using kit. So this is the kit 8051. Okay, this is actually in the assembly program. You can observe a port 0 is used. This is port 0. This is port. You can see here label is there. Port 3, I think. This is port 1, and this is port 2. This is 8051. This is a cable which is connected to computer backside. Parallel pin port is there. There you have to connect, and this is through adapter. You have to connect power supply. This is 8051 microcontroller. So through this FRC cable, flat ribbon cable, okay, you can connect which port is programmed. That port you have to connect here, and you have to connect to this stepper motor. So this is a ULN 2003, which is increases the current value, because the output, if you directly connect without this, if you remove this chip, then current will be less and the motor will not rotate. So for rotation, it requires more current. So you have to use this ULN 2003. I see. So now after the program, okay, you can see the motor will rotate now. See, it is rotating anti-clockwise, because in the assembly program we are given the reverse sequence. But for our C program, what you have written, will execute. You can expect clockwise direction. Okay. So now see here, the program is written for anti-clockwise. C639. This is for anti-clockwise. Okay. And in our program, we have written code for clockwise. 6C93 means it is clockwise. If you give 396C, see, there is no rule that you have to start from C6 only. You can start from 6. You can start from C, next 9, next 3, next to 6. The sequence should be C693, C 6C93, 6C93, 6C93. Then it will rotate clockwise. If you give opposite 39C6, 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 it will rotate opposite direction. So in that assembly program, we are good. So that is one way of verifying the output. For example, if your kit is not working and if your program is correct or not, if you can show the output in simulation also. For that, you should show that in port 1 you are getting this sequence. So for that, what you can do, this is optional part. Okay. So for that, what you can do is start debug. Then you have to go to logic analyzer. So this is a logic analyzer. So once you open this logic analyzer, okay, you will get like this. So then you have to go to setup. Okay. So I am deleting all the previous one. So next you have to click new. So you have to click port 1.0. Second time port 1.1. Next one more time port 1.2. Next port 1.3. Okay. By default, you can see port 1. If I click on the first one, port 1.0, this one red color. Red color is port 1.0. So that you can change it to bit. Second one also bit. All are in now. We have to see in bit. Individual bits we are checking. Those bits are actually coming 1 or not, 0 or 1. Okay, 0 is red color is 1, port 1.0, and black color is 1.3. So now you have to click close and now click on run. So this you can verify the output at your home only, whether are you going to get the same sequence or not. Now click on the run button. Okay. See, you're going to get this sequence. If you are not coming, you have to click all and you have to click zoom. If you are in your system, if it is not visible, click on all, then click zoom. Okay. And you can stop and check whether sequence are coming or not. See here, first sequence. See here, 0011 is coming. Next sequence is 010019. Okay. This is MSB. This is LSB. So this is 1009. This is 00113. This is 6. This is C 1100. This is 9, 3, 6, C. like that. So this is simulation output. Just you have to show the sequence is coming or not. If you connect this to the gate, definitely you're going to get the output because you are giving the sequence continuously. Okay. If you are writing instead of while, if you are giving a for loop, after 200 steps, see each are one step. At any point of time, only two coils are one. You can observe here. Like after 200 steps, the sequence will stop and motor will stop rotation. Here we are writing while one, so it is rotating continuously. Okay. And how stepper motor will rotate? Already shown, no? So this is anti-clockwise. If you touch on this, if you touch on this, you can feel that steps. So you can observe here there is a screw which when it is rotating, okay, you can see this screw. If you connect some screw, it will rotate. So if you want to rotate stepper motor faster, decrease the delay, and if you want to rotate the stepper motor slower, increase the delay. How to increase the delay? Here in the delay program, you give FFFF. If you want to decrease the delay, you give 00FF. Okay. If the delay is very less, it looks like normal DC motor is only running. It will rotate faster. So if you want to observe step between the rotation, give suitable delay. Okay, that is left to you how much delay you want to give. Thank you.